In this video, we're going to talk about solubility and net ionic equations. We'll also be making another video where we talk about going in detail about the solubility rules. But for now, what I want you to do to predict whether or not something's capable of dissolving is to use Coulomb's law, which we know as the force of attraction being equal to the magnitude of the product of the charges over the distance squared. So really what we're going to focus on is the product of the magnitude of the charges, and we're going to look at the absolute value of that number. If that number happens to give you an answer equal to or greater than 4, we're going to predict that it won't dissolve. And we can say that that's probably what's going to happen because it's probably going to take a lot of energy to break apart the ions in the crystal lattice, more so than the energy that would be released as the solution forms. So this works about 80% of the time. You have some troublesome ions, however, that are kind of going to break that rule. Hydroxide and silver, those both have a magnitude of charge of 1, silver being positive, hydroxide being negative, but they usually aren't soluble compared to other positive and negative 1 counterparts. Sulfate is negative 2, but will tend to form things that dissolve, with other positive 2 or greater metal ions. So when we have a chemical reaction and we write out a solution reaction, you have aqueous components that are being added to each other and they produce a solid product, but you also have usually something else that's still labeled aqueous. Like in this example, we have sodium carbonate, which is aqueous, reacting with calcium chloride to produce calcium carbonate, which is a solid, and salt, which is aqueous. So we say these are aqueous, and we've kind of given you those to this point, but now we're going to expect you to be able to predict when something's going to be aqueous. So if we look at these substances, sodium and carbonate, sodium has a charge of positive 1 as an ion, carbonate negative 2. You multiply those values and you get a number of 2, which is less than 4, so therefore we'll say it will dissolve or will be aqueous. Calcium chloride, positive 2, negative 1, that's a product of 2, therefore we're going to say that it's likely to dissolve. Calcium carbonate, positive 2 and negative 2, that gives you 4, which meets the equal to 4, therefore we'll say that that will form a solid. And then sodium chloride, positive 1, negative 1, product of 1, not even close, that will dissolve. Now, when we look at what's actually happening in the reaction, not everything's truly involved. All right? Sodium and chloride, for example, they're ions in the beginning and they're ions at the end. They don't really undergo a change, and therefore we consider those to be spectator ions because they don't actually participate in the reaction. This is what a complete ionic equation would look like. You essentially take your compounds that you start with and then break them up into their ionic components, except for the one that forms a solid. So the ones that are ions at the beginning and at the end, you can remove those from the equation when you're making the net ionic equation, which only includes the substances involved in the formation of the precipitate. So calcium plus 2, aqueous is an ion. Carbonate, minus 2, aqueous, reacting to form calcium carbonate, and that would be the net ionic equation.